So we're back. So the lesson learned with the tragedy of the commons, or the sub-optimization problem, is that we need to understand the interaction among all of the components, all of the parts of the system. Again, they mentioned the self and being selfish inside this particular video, which is lovely. But the lesson learned is that you just needed just enough to get the job done. Is sort of the wise words inside this particular part of the problem. I'll bring this back to the beer game that we played. Not that anybody made their choices poorly, and no one was behaving selfishly, but everyone was behaving in their own self interest. Pardon me. If you recall, there was this. Oh, by the way, each case of beer will cost you 50 cents per week to hold it in your inventory. But watch out, it costs $1 for every case of beer that you're short. So don't ever be short. And of course, there's a reason why the game is played like that, to try to scare people emotionally into being self aware that they don't want to run short. So yeah, when we started out the game, we only took 4 cases of beer once a week. I don't believe that the beer game in this particular video is connected in any way, but if you recall, there were 12 fish in the pond, and then each day the fisherman took 4 fish, and then it replenished itself. And that's exactly the way that it worked inside the beer game. If you recalled, we started the game with 12 cases of beer in inventory, and then I started as the customer. I started ordering 4 cases of beer, and then your trucks were delivering 4 cases. They weren't overnight; they were every 2 weeks or every week. So if I kept on only ever ordering 4 cases of beer, and you kept on ordering 4 cases of beer from your suppliers, the game would never have any problems, which is exactly what we saw inside this video. Now that I think about it, perhaps they really did design it after the beer game. But what, of course, was happening was I was selfish, and I started ordering 8 cases of beer. I doubled the number of cases. Now, thankfully, the system was able to react to that, and perhaps if you would have just gone ahead and increased your orders to 8 cases per week, perhaps there would have been a little bit of a backlog that would very quickly go away. But the problem, of course, was you're being very self-interested. No one's being selfish. No one's being the bad person here. But oh my gosh, we don't have enough information, which is why why the entire system is starved for information. What if the customer doubles again and orders 16 the next week? Then we'll be cut short. So I better order 16. So because everyone was following their own self-practical interest without any other information, you were looking out for yourselves, and you were told to look out for yourselves. You were told to look out for your individual business. We started ordering 16 cases a week, or 32 cases a week, or 64 cases a week, and it completely depleted the system. We ran out of beer, which is exactly what happened. We ran out of fish. So the sub optimization problem, or the tragedy of the commons, is what that is particularly called. So yeah. So just enough to get the job done, unless you know something different. If you know something is coming down the pike, again, keep on talking about what we're doing right now inside COVID, because we know what's coming down the pike based on what's happened in other countries. We're taking some pretty drastic measures to have everybody stay home, rather than just go about our business. So it's all based on information. If you have the information, then you can make an informed decision. So how about this change of game? So again, all of these things have been game changers. What about change of game in the first place? Well, this happens all the time. We're constantly innovating. Dissolving a problem or solving a problem generates a whole new set of problems. So like, well, wait a minute. Once you solve or dissolve a problem, it makes it go away and everything's perfect. Well, that's not usually the case. As soon as you go ahead and dissolve a problem or solve a problem, it generates a whole new set of problems. Thinking of an example. Example might be thinking back to if you went ahead and applied for your learner's permit at 16, or got your first car. Go ahead, and maybe the problem was I finally have my learner's permit, or I have my license, and I need to get a car. So you go ahead and you work like crazy, you get a couple jobs, and you save up a lot of money, and you go ahead and you solve the problem of getting a hold of your first automobile, and you do it, and then you have to pay for insurance, and you have to pay for licensures, you have to pay for registration, you have to upkeep the car, and you need to replace the oil changes, you need to pay for gas, and you need to go ahead and there's lots of other things that have to be done that may become problems that weren't problems if you didn't own a car. So it's not that these new problems are bad, they just happen to be associated with now that things have changed. There's a whole new set of things you need to do. So again, this a new competitive game emerges as soon as a competitive challenge is met, which is what we're talking about. Going back to cars again, this is probably why I'm stuck on cars, because I knew this slide was coming up. Henry Ford, we keep on talking about Henry Ford being a great person. Produced mass production. He solved the production problem. Unfortunately, he happened to use people as robots. But rather than only making having a whole bunch of very, very talented, highly trained people walk into a garage, be handed all of the parts, and then out rolls the finished car, the people who would do that would have to know how to build an entire car. That's different than having a person be trained to just put on the right front tire. It doesn't take that much training to have a person do that. So that's how he changed that. He made the moving assembly line such that he could produce many, many, many cars. The problem before was there wasn't enough cars to go around. Now he produced many, many, many more cars. Unfortunately, because the entire machine or the entire system only made one car, the new problem was how do you handle customer choice? How do you change the design without having to change the entire machine, the entire factory? And Henry Ford is very, very famously quoted as saying, "The customers can have any color as long as it's black." So very famously, the Model T only came in black. You couldn't go buy a fire engine red Model T because it didn't happen. So the difficulty here, or the solution learned here, is that the solution leads to the next problem. So in this case, we say that about the assembly line, or Ford's invention of the assembly line, definitely changed the game when it came to mass producing items. And then the next thing that happened was how can I go ahead and get some customer tastes and customer individuality into my product, rather than actually stamping out the same product over and over again. It turns out that the Model T, the same Model T, the same car, was actually produced for almost 20 years. So imagine buying a car that's brand new, but was designed 20 years ago. It's sort of difficult to think about that, but that's how it works. So we're finally here to our last topic, the shift of paradigm. And again, this sounds like a business muckety-muck type word, but it just simply means a change in the nature of reality, a change in the way that you look at things. So we do this all the time in ISBIT. We do this all the time in college. We try to change the way that which analogies we use, how we look at things, what examples we use to try to change the way that we approach problems. So there are three models that we happen to have. We're talking about a change in the nature of reality. And what's the reality of things going on? There's the mindless machine, which we just heard was Henry Ford. There's the uniminded biological model, which is treating a business like a person, or a tree or a crop, where there's a single brain and there's a whole bunch of other parts of the body. And then we have our third version, which is called multi-minded social, more of a team. We're going to take a look at all of these guys in succession so we can get a better understanding of what's going on. So yeah, the mindless machine model, it's a mechanistic view. It's mechanistic being machines. It's definitely based on the Industrial Revolution, and of course the Henry Ford moving assembly line was part of that Industrial Revolution. And it is based on the idea that we can go ahead and use people as robots. So even though we don't have the technology back around the turn of the last century, around 1900s, we were still 50, 60 years away from the digital computer. We needed this factory to do a whole bunch of repetitive things, but we just didn't have the robots to do it. So we hired people to stand in as robots. So whenever you hear my phrase, people suck as robots. People don't suck themselves, but when asked to pretend they're robots, which they are not, they suck at it because we're not robots. But over the past 100 years or so, we even still have manufacturing companies now. Thankfully, a lot of them are going away. Who consider using people as robots. So in this case, the lesson learned by using this mindless machine model of Henry Ford is that machines can be built with people as parts. So imagine you're Henry Ford. Imagine it's 1910. You want to build this giant factory and you want to produce a whole bunch of cars, but you don't have a machine that can move the tires from one side of the factory to the other side of the factory. So you just hire some people to do it, and that's great. But you're treating people as parts, and that's how the mindless machine model works. The uniminded biological model, of course, the single-minded biological model, is a biological view. And the idea is a change in paradigm. What if we think about a business as being alive, not just a machine with a whole bunch of people as parts, but what if it's alive? And what if machines, have a brain and they think about things, and the machine wants to live, and the business wants to live, and it wants to grow. So in this case, the idea is that we're going to look at a business and see what the business can do to survive, and what the business can do to grow. Because that's what you get a baby hamster. That's what you do with it. You make sure that it's going to survive. You don't want to kill it. It's not like a Tamagotchi. And then you want to make sure it grows as well. So it turns out that the brain of the organization can learn. It can use its senses, and it can grab some information, and it can use that learning to survive and grow. So in this case, the change in paradigm, the idea was, rather than hire people as robots, what if we hired some people to be the brain of the organization? So what we'll do is we'll hire some people to do their job as being the brain. We call these people management. And then the rest of the people will go ahead and we'll just use them as robots. So we're getting close. We're getting there. Maybe not close, but we're definitely moving. Everybody's a robot. At least now some people are hired as people, and the rest of the people are hired as robots. So the lesson learned was that we can go ahead and we can create something called management. They will be the thinking people, and then the rest of the people will be the robot part. Now, of course, there's the third part. We like to think that the third part is the most evolved, and the third part is where things, at least we're happy with them right now. This is the socio-cultural view, or the multi-minded socio-cultural view. This is where every person's mind, every person's brain, because they have one, is important. Don't just hire somebody and then completely ignore that they have a brain. That's not a very smart thing to do. So in this case, rather than being just a machine, or rather than being a plant or a baby hamster that wants to survive and grow, what if it's an organization of voluntary people? What if it's a team of people and they're there for a purpose? Maybe their individual purpose is just to do a good job, earn a paycheck so they can go home and take their piano lessons because they're learning to be a virtuoso piano player. That's fine too. But the idea is that the team members are there. You want to keep them happy. You want to give them a purpose. You want to give them some goals to achieve. You want to see them be safe. Of course, you want it to be a good cultural place to work, and you want them to want to show up to work rather than just showing up to work to be a robot for the day. So in this case, the organization used the brains of all of the members. Even if somebody's doing a lower level job, not a robot job, but a job that's more fundamental, they still can perform that job as a thinking human, not just as a robot who's pushing a broom. Say that they really are doing maintenance, perhaps. That really does involve using a broom or using other robots to do brooms, but noticing a machine is leaking, or realizing that you need to use this broom because something keeps on overfilling or spilling, that's using your brain and figuring out, hey, there's something wrong here. I'm going to increase this system rather than just being a robot that cleans up an oil spill every day, even though it's pretty obvious that the machine is leaking oil. You should probably go ahead and fix that. So in this case, the lesson learned is that we're going to hire people to be people, and we're going to use robots to be robots. So again, it's not as if Henry Ford was stupid. He was a very, very intelligent person. It's just that he was born about 100 years too early. He started his company when in his 40s, and we're talking 1906, 1907. They just didn't have any robots. There were no robots running around. In fact, I don't think the word robot was used yet. So he couldn't build robots to do robots. There were a lot of automated machines, but they definitely weren't robots the way we know it. So it turns out that our own technology is allowing us to change our paradigm and to hire people and have them do people jobs, and then hire the robots and have them do robot jobs. Another shift of paradigm is the change in the method of inquiry. So rather than using an analogy like a machine or a plant or a bunch of people, we can also figure out how these individual values interact with each other. So there's two of them. One is called the analytical approach, where you analyze something, you take it apart. In this case, the individual things that can change they are independent. They don't depend on each other. So again, I'm talking about the new Corvette with a 1,000 horsepower engine. The fact that the horsepower engine can provide 1,000 horsepower, that's fantastic. But yeah, it's connected to the drivetrain. It's connected to everything else. In this case, an analytical approach would say, no, let's just throw it in there. It should be fine. A systems approach, of course, is what we do here. Is why we're taking this class, and that's to know that all of the parts are interdependent. If someone really, 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 really wants to put a 1,000 horsepower engine inside a car, we're gonna have to upgrade all the other components to make sure the damn thing doesn't fly apart when we go ahead and rev it up. So in the analytical approach, the whole is just the sum of the parts. What you do is you grab a bunch of Legos, you snap them all together, and then when you're done, you have whatever you snap together. In this case, whenever we go ahead and we try to figure out how things work, usually we look to the inside for answers. This is sort of the traditional way that the physical, the life, and the social sciences do. If we want to go ahead and do a study, what we're going to do is we're going to take a few samples. We're going to isolate people. We're going to isolate some sort of feature. We're going to go ahead and capture a particular species if we want to study it rather than studying it in the wild. So then we're going to either literally dissect it into parts. In this case, studying an animal means waiting for the animal to expire or actually making it expire. Or you wait until an accident happens, unfortunately, and then you look at the parts that are left over. You look at the parts, you analyze individual parts and see how they fit together, and then you sort of imagine or you sort of design or foresee how they could fit together for the whole. And again, that's the analytical approach, is looking to the inside for the answers. In the case of the systems approach, which is the other side, this is the idea. We're going to go ahead and look at all of the components at the same time. We're going to examine the entire set of interdependent variables, and then we're going to put each part in the context of how it connects to the other parts. In this case, we're going to look outside for the answers. This gives us the phrase, the whole can be greater or less than the sum of the parts. I've mentioned this a few times in class. Sort of like a baseball team. So a baseball team can have different parts. We need all the different players on the field. We need the equipment. We need the rules. We need the umpires. We need the field itself. But then how we play the game and how we practice and how we work together. If we do that really, really well, then we start winning games. So just because you know what the positions are in baseball, and you may even know the names of the plays and all of the rules and memorize the rule book, doesn't necessarily know that you immediately know how games are won. So winning a game happens to be something that's outside of looking at the individual parts. So what I want to take a look at quickly here, I know this is getting a little bit long, is to take this shift of paradigm and look at these different values. So we had three shifts of models. We had the mindless machine model, we had the uniminded biological model, we have the multi-minded social model, and then we have the other two shifts we did. We had the analytical and we have the systems. So let's take a look at these guys really, really quickly. So we're going to combine those. So the analytical, so the row is analytical and the column is mindless machine. When you combine those two things, you get the interchangeability of parts and labor. So again, this is Henry Ford. And yes, Henry Ford did not have the technology to make robots, but in using people as robots, he was able to go from 2 cars a day, because it would take multiple teams of craftspersons to put an entire car together. His factory went from making 2 cars a day to 6,000 cars a day. So he didn't double it to 4. He went from 2 to 6,000. That's a huge, huge thing. Unfortunately, along the way, using this invention of using people as parts or people as robots, not the greatest thing we've learned, and thankfully we're beyond that because we have actual robots, but still, that's where we're at. So he solved the production problem sort of change of game wise, but then he created a new problem. That was the demand for product diversity. And also, large machines are difficult to operate and control. It takes a long time. He eventually did upgrade the Model T to the Model A, but he had to close the business, close the factory for an entire year, send everybody home. He had to lay them off for a year, rechange everything, things that were automated, and then reopen it with the Model A. So it was not possible, no, not convenient to do what needed to be done. So more, newer people needed to work at that. As we move over, we're still in the analytical row and we're going to the uniminded, and we have diversity and growth. It turns out another car company, this is General Motors, Alfred P. Sloan is not a person who invented General Motors, but was the very famous CEO there. People may be familiar with the Sloan School of Management at MIT. He went ahead and said, hey, how can we handle the problem that Henry Ford just created? How can we make changes and make design changes to our product and still keep the business working and still keep using people as parts? Unfortunately, we hadn't had robots yet. So he decided that we're going to have a few people rather than just Henry Ford. We're going to have a few people that are going to be our designers and our management, and they're going to work through how to go ahead and have the company adapt to change. Not everybody is a part of management. It's sort of like the same way that the military is set up. You have the officers, and then you have the enlisted. Not that the enlisted is, here I go, caught myself up. Not that the enlisted don't have brains. It's just that they're used as parts. Go blow that up and follow orders and go be a robot. And now, of course, we have robots that actually do that. We have autonomous vehicles and drones and like to do that. But back in the day, you had to have officers that were supposedly paid to think, and then you had enlisted folks that were paid to do. Same thing with this business over here, making cars. We had management who were paid to think, and we had workers who were paid to do. So what was solved was a control of large organization. And unfortunately, what was created, the new change of game, was how does a business learn? How do we know what's coming next? How do we know what the next innovation is going to be? And then we also had to worry about, hey, what's this reality? You're going to get some, surprise, the workers really do have a brain, and they're going to have some really good ideas that are either sometimes or many times will be in direct conflict to the management folks who aren't working on the floor. How are you going to handle those conflicts? So we need some more evolution that way. Still in the analytical row, we're up to the multi-minded social side now. This is called participative management, where we allow the workers to have a say. These are self-organizing systems where the individual team members have more of a say as they do things, but they're still enlisted versus officer, but now they have more of a say. The Tavistock Institute is an institute that's sort of just as famous as the Sloan School of Management at MIT. The Tavistock Institute happens to be a British institute over in the UK. They're the ones that sort of brought this way of thinking to mind. It's still analytical. They're still looking at individual parts, but thankfully they're realizing that everybody has a brain. What they solved was that they solved the need for individual expression. The idea being that companies should have a mission statement and goals that they give to the workers. And of course, if you go to LaSalle's website and you click on it, you're going to read the mission statement. We still use this today. In fact, ISBIT has a mission statement. If I can pull it out of my head real quick, it is developing engaging team members that are eager to explore the frontiers of innovation. So we want to have effective team members is sort of our mission statement. So having a mission statement and letting everybody who has a brain know where we're going, but still pretend you're a robot when you need to be a robot is sort of where we're at here. So what was solved with this individual expression, but now we need to get everyone to agree, and we need to have a lot of management of conflict when people don't agree. So our last three, let's switch the systems. Let's go ahead and come down, and now things are interrelated. We still have a mindless machine. We're back to the military again. Again, the military is not thinking that individuals don't have brains, but depending on your rank and depending on how you are enlisted and where you are officer-wise, that is the job, that is the duty that you're expected to perform. It's called joint optimization. We're still talking about people doing their jobs without thinking. This is where there's so much training comes in. Unfortunately, this also works inside inside other professions like doctors and nurses. Of course, doctors and nurses are extremely intelligent. They use their brains a lot. Unfortunately, when there's a huge emergency, and when all of a sudden the operation goes sideways quickly, there's no time to Google what to do. You just have to act, and that's sort of where this training comes in. We're gonna know that people have very smart brains and lots of capabilities, but they're trained to act sort of mindlessly, to go ahead and do things without thinking. So in this case, it's act before you think. If anybody has ever had any martial arts training, this is why you go through a whole bunch of sparring training. After you put in a few hundred hours of sparring training, the idea is if someone goes ahead and sends a kick or a punch your way you're not expecting, you sort of react without even thinking about it because your body knows how to react before you do it. So in that way, that's what we mean by mindless, not that the people aren't smart enough to have a mind. This was surprisingly enough, it was adopted by the Ford Motor Company after we started getting some robots, which is pretty cool. What it did was it solved this interdisciplinary or interdependency of variables, but unfortunately, what it didn't solve was again this idea of, hey, if we're talking about people and the people do have time to think about it, they actually have a choice. So how are we going to go ahead and do that? Almost done. Systems, paradigm, and uniminded. This is flexibility and control. This is which is currently used now, actually in modern times. It's called the Toyota production system. It's very popular. Not just Toyota uses it. Many companies use the Toyota production system because it definitely uses the idea that the workers, we want them to use their brain as they go through, but there's still sort of this division between the management on top and the employees or the team on the bottom. It turns out that before Toyota came up with the flexibility and control in the Toyota production system, if they wanted to change a part of a car and a machine, it would take 3 days. That's definitely better than the first Ford plant, which took 1 full year, 365 days to go from the Model T to Model A. You can change a die in 3 days, but in Toyota, they can change a die in 3 minutes. That's an advantage, and now companies are using this system so that they too can change a die in 3 minutes and make a different version of a car. This is why we have so many different versions of the same car, different spoilers and different grills and different lights and different whatever, because we can change the machine and make a whole bunch of customer choices of the problem. So they solved how to react quickly to the changing environment. Pardon me. The next problem, of course, was to anticipate what those required changes are. And of course, the problem now is if they anticipate a huge run-up on, say, red Toyota Camrys, and they go ahead and produce a bunch of them, and then all of a sudden red Toyota Camrys aren't really selling, the forecast was wrong, so we have to worry about that. So our final one, and of course, this is where we're going to land. This is sort of what the book is all about. We're in the systems row, the systems paradigm. We're in the multi-minded social row. And this is called, by the authors, redesign. The idea of going back in and taking what you have and adjusting it. And again, after a while, after adjusting it, you have to sort of start from scratch rather than patch like we saw before in the earlier portion of this particular chapter. This is actually, we talked about this, the Sloan School of Business up in MIT. It turns out that the #1 business school in the United States, we're going to throw some Philly pride in here, is the University of Pennsylvania's Wharton School of Business. And a professor there, Russell Ackoff, is the person who invented this idea or developed or popularized this idea of systems thinking and interactive management. This is where this book that we're using comes from. So our book is out of the Wharton School of Business. So if anybody asks, what do you study at LaSalle? Well, we study the same books that they study at Wharton. In this case, we're going to go ahead and just state it that systems have a purpose rather than being just formed as a reaction. So rather than being, oh, I should assemble a team, or I should go ahead and hire a business to make this, rather than just having something happen and then assembling a team. In this case, we're going to have the team be there for a reason. We're going to go ahead and update that reason every day. So that reason, it sounds like a mission statement, but it's going to be like, oh, we want to provide customer service, so we want to provide the best product. And again, in the case of Isbit, our mission statement, our system, our purposeful mission statement is developing effective team members. That's what we're after. We want folks to work as a team. We want folks to solve difficult problems as a team. So in this case, the thing that was solved was that the system can choose its own future. So rather than waiting for the projections, hey, we need 1,000 red Camrys, they can go ahead and they can lead rather than follow. They can use some marketing and say, we're going to create some demand, or we're going to go ahead and talk to our customers who may know about this demand before it actually shows up. So what we're going to do is we're going to go ahead and use the folks that are inside this system. We're going to call them stakeholders, and we're going to design the future, and we're going to realize it through successive approximation, through this redesign, rather than design it, see if it worked. If not, destroy it, start again. We're going to go ahead and we're going to experiment as we go. So what was solved was the dependence on forecasting and what it remains to be done, and it's a giant mouthful. And if we had started with these red words inside a business book, people would put it down right away and say, "Oh my gosh, what a bunch of gobbledygook! It doesn't mean anything." But the team members, in this case, we're going to upgrade the work to stakeholders. So every member of the team has a stake. They're all members. They all have stock options. They all have importance. They're all wearing uniform. They all wanted to do well. Stakeholders must learn how to use what they already know. Okay, it sounds like a knowledge worker. We need to make sure that we are using what we know. We're using our brains. We're not just robots. They need to learn how to realize what they don't know. Okay, that's pretty cool. So maybe you realize what you don't know by reading and surfing the web and watching YouTubes and watching videos and talking to friends and reading articles and whatever. You go out and you just engage and see, hey, I don't know about 5G, or hey, I don't know about 3D printing inside biological materials. And they have to learn how to learn what they need to know. So in this case, this is sort of a charge. It's a commandment. It's sort of a challenge to the people in our organizations, our stakeholders who are humans, to act human. Don't just do your job. Don't just pick up your pencil and put a check in the box because that's what you do every day. And after you do a few thousand checks, you can go home at 5. That's not what we're talking about. You constantly have to be engaging your brain. You constantly have to know and get good at what you already know and get better at doing your job. You have to constantly be on the lookout to learn new things and say, hi, hey, I don't know that. And then when you do spot something that you don't know, you have to be good at figuring out how to get the new information. So it's this big red thing down here that we've pretty much been talking about all semester, but now I'm specifically bringing this out and calling it out and say, hey, this is the central, pardon me, this is sort of the central object of Isbit, which is why I have the Isbit logo down here. I'll go ahead and pull this guy over. It's a commercial for our major. This idea of developing effective team members. Effective team members are those who do just that. Effective team members use their skills, they improve their skills without even being asked, and they acquire new skills when they realize they need to. So it's sort of like, rather than waiting for a robot to upgrade itself, or waiting for your phone to upgrade itself, which does not happen right now, you have to replace the robot or buy a new phone. Humans can upgrade themselves automatically. So the idea is you hire a bunch of humans, you have a whole bunch of humans on your team, and then what happens is the humans, because you've paid good money to hire humans and not robots, they are good at getting better at what they do, letting people know what's coming down the pike, and then figuring out how to do better at what's coming down the pike and being ready for it is how we anticipate in the future. And that saves the businesses from falling into this trap of being unaware and knowing how things work out. So let me push this button here. So this is me. Fantastic. I've been talking for a while, and I'm going to work on the next topic, and I'll see you in a little bit. Thanks.